steel tubular products. The cross-roll piercer, followed by the push bench, and finally the stretch reducing mill. Continually cast round steel billets with a diameter of 230 millimeters are used to manufacture the seamless tubular products. The billets are produced by another voestalpine Group company in Donawitz, one of the world's most advanced steel plants. Most of the continuously cast billets are cut to the required lengths with two carbide-tipped saws. A small percentage of the billets passes through a preheating furnace, and they are then cut to length with billet shears. An automated, computer-controlled rotary hearth furnace preheats the billets to a forming temperature of around 1280 degrees Celsius in preparation for rolling. The solid round billets enter the Discher piercing mill. Rolls set at an angle to each other feed the billets over an internal piercer at a speed of 1 meter per second, turning them into tube shells. Tools called mandrel bars are inserted into the pierced shells. The mandrel bar and the tube shell are pushed through a stand of forming rolls. This process elongates the pierced shell down the length of the mandrel bar, creating a seamless tube. The pierced shell is elongated up to 17 times its original length and is now called a hollow. The maximum length of the hollows is 22 meters and the minimum wall thickness 3 millimeters. The hollow with the mandrel bar still inside is moved through a reeler where the rolls expand the hollow, enabling removal of the mandrel bar. Before the hollow enters the reheating furnace, its wall thickness is controlled over the entire length with a radiometric gauge. After the radiometric inspection, the seamless hollows are heated in a computer-controlled walking beam furnace to the required rolling temperature for the subsequent stretch reducing process. The hollows rotate as they pass through the furnace to ensure that they are uniformly heated. The 28-stand stretch reducing mill gives the tubes their final geometry with defined diameters and wall thicknesses. After the rolling process, the wall thicknesses are verified over the entire length using a radiometric gauge. The results of the inspection are graphically displayed, documented, and used to control the rolling process. The tubes, which are now up to 150 meters long, can be cooled rapidly to achieve specific mechanical or performance properties. Once the tubes have cooled, two carbide-tipped layer saws cut them to multiple or final lengths. The tubes then either undergo further processing or are sent as pre-material to drawing or drill pipe manufacturing plants. Tubes for commercial vehicles and the automotive industry. Mechanical tubes. Boiler, pressure and high temperature resistant tubes. Tough tubes. Pipes for the oil and gas industry. When required, tubes can be shipped with ends upset according to API specifications. Special upsets for drill pipes, integral and premium connections are also available. The pipe ends are heated to forging temperatures with induction heaters and are then upset to the required contour in up to 3 forming steps. The forging is done by using either a mechanical or a mechanical hydraulic upsetter. In the austenitizing furnace, the pipe is heated to a temperature where its microstructure changes. This enables the pipe to be hardened by rapid cooling in the quenching process. The pipe is then tempered to the desired strength level in a temper furnace. Rapid cooling of an austenitized steel creates a defined microstructure that is extremely hard and strong. The steel has to be hardened in this way before it can be tempered to the required strength level. In the tempering furnace, the hardened tubes are heated to a specific temperature and held at this temperature for a defined length of time. This leads to the required steel grade. The heat-treated tubes are straightened in rotary straightening machines. Each tube is non-destructively tested. The testing consists of an electromagnetic inspection, and the pipe ends are then inspected using ultraviolet magnetic particles. During the electromagnetic inspection, the wall thickness is measured by phased array ultrasonic methods. In addition to the electromagnetic inspection, the pipe may be inspected ultrasonically outside the production line. The scope of tests includes inspecting the inner and outer surfaces for longitudinal, transverse and oblique flaws, measuring the wall thickness and searching for laminations. These inspections are made over the entire length of the pipe. 2 threading lines, each with 4 CNC threading machines, are available for finishing OCTG and other tubular products destined for the oil and gas industry. These machines cut connections at the ends of the tubes, ranging from simple API threads to sophisticated gas-tight premium connections. The couplings required for producing finished OCTG are also made from seamless tubes. These tubes, referred to as coupling stock, are cut into blanks of specific length. CNC machines then cut threads in the blanks to make OCTG couplings. After dimensional inspection and non-destructive testing, the couplings are phosphated and moved to the thread lines, where they are installed on the threaded pipe. The couplings are screwed onto one end of the pipe. During the threading process, the make-up torque and make-up process are automatically monitored and documented for every connection. Hydrostatic testing involves filling the tubes with an oil-water emulsion, pressurizing the emulsion to a specific level, and holding the pressure for a given time. The pressure and hold time are dependent on the dimension and grade of the pipe. The threaded pipe ends must be protected against mechanical damage and corrosive environments during transport and handling. After hydrostatic testing, a corrosion-resistant grease is applied to each exposed thread, and a thread protector is screwed onto the exposed end. In the last step of the production process, the tubes are weighed and measured. If required, both the tubes and couplings are stamped with unique identifications. Production and order-related data is stenciled along the body of the pipe. Finally, the tubes are strapped together in bundles and prepared for shipping.